Hey, we are live. So the first thing I'm going to do is, today is Thursday. It is 3/19/2020, and hopefully you guys are staying up on this. Please continue doing the homework, because I'm going to put a homework grade in here at the end of this chapter, and then if you are doing the homework consistently, then it'll bring your grade way up. If you're not doing it, it's going to bring your grade way down. So it is super important that we do the homework. Anyway, back to the math. So first thing I'm going to do is show you the answers from yesterday's stuff. And again, no work, no credit. Okay, again, no work, no credit. But here's what I have for answers. 3 square root of 3 over 10, square root of 2 over 5, square root of 15x over 20, 2 times the cube root of 4, 5 minus 5 square root of 3 over 6, negative 3 plus 3 square roots of 5 over 16, negative 4 square roots of 2 minus 20 square roots of 3 over 73, square root of 15 minus 5 over negative 2. 21 is about 38 meters. 22 is about 9 square root of 2. 23 is a negative 6 square root of 5 plus 6 square root of 2. 24 is a 9 square root of 2 plus a 12 square root of 3. 20, I have a 2 square root of 30 plus a 4 square root of 5, and 26 I have a 4. So again, you may want to do these on a separate sheet of paper, because I don't know if there's enough room to show all this work. Okay, anyway, that's yesterday's work. Now, today, before we do anything, I want to go back on today's notes, and the first thing I'm going to do is a little bit of review, okay? So, kind of like a warm-up, but we're going to just do it together. So the first review question I have, example 1, we'll call it a warm-up, would be like a 3 square roots of 24x to the 7th, okay? So let's do this together. 3 is a regular whole number. Leave a 3 out there. I'll let you write this down, okay? The 24, I'm going to break up into its multiples. I like perfect squares, so we're going to go the square root of 4, the square root of 6, because 4 times 6 makes 24, and 4 is a perfect root. X to the 7th, I need an even exponent, so I'm going to go ahead and rewrite this as the square root of x to the 6th times the x to the 1. Hey, all those emails coming in, are you guys doing your homework? Good job. So now, you ready? Square root of 4 is 2, just a regular 2. Square root of 6, we cannot do anything with it. I'll take half of this exponent. I'll have an x to the 3rd. And then these 2, square root of 6 is a bad number. It's an ugly square root number. And the x, plain old x, you can't do anything with. So we leave those two alone. 6x. Simplify this to a 6x cubed, square root of 6x. Okay, boom. Problem number 1. Okay, problem number 2 in our warm-up, because I think we need to practice this. Square root of 3 over 5. Okay, go ahead and write that down. If you need time to pause the video, you can. So, here's the deal. This is the same thing as 2 different square roots. Square roots of 3 over square root of 5. The rule is you can't have a square root in the denominator. So I like to fix the problem with problem. So I'm going to multiply by the square root of 5 over the square root of 5. When I do that, I wind up with a square root of 15 over the square root of 25. Square root of 25 is 5, right? Square root of 25 is 5. Square root of 15, square root of 15. Now you'd like to divide, and that is the answer. I would like to divide the square root of 15 by 5. That is not the way it works. If I take a look at this, I go the square root of 15 is some ugly decimal number. So you can't divide this ugly decimal number by 5 and get a nice number. You can't. So you just leave that answer. Okay. Last problem on our warm-up. Let's see if we can do this. Example 3. If I have 2 times the square root of 3 plus 1. Oh, that's a beautiful sound. Nice job, you guys, on your homework. Times 4 square roots of 3 minus 2. Alright? So again, this is just kind of like a warm-up, and then I get to the lesson. The lesson's actually pretty easy today. I'm going to FOIL. I'm going to double distribute. 2 square roots of 3 times 4 square roots of 3. 2 square roots of 3 times 2. Then I'll go 1 times 4 square roots of 3, and I'll go 1 times negative 2. So here's how it's going to work. 2 square root of 3 times 4 square root of 3 is an 8 square roots of 9. 2 square roots of 3 times a negative 2 is a minus 4 square roots of 3, because you multiply the whole numbers, and you still have the square root of 3 with you. Okay, 1 times 4 is square root of 3. Multiply the whole numbers, I get positive 4 square root of 3. And then finally, 1 times a negative 2, whole number times whole numbers, and minus 2. Okay, now, hey, this one turned out pretty nice because these cancel. I like that. Doesn't always happen that way. Those cancel. I'm left with 8. Oh, I can take the square root of 9, can't I? Square root of 9 is 3 minus 2 because those are gone. 8 times 3 is 24 minus 2. My answer is 22. So all my square roots disappeared this time. Like that. Okay, we'll keep doing these little warm-ups because the square root stuff is going to be hard for you. Alright, so let's move into the lesson. And again, you can pause this anytime you want. Okay, so today, and it's not a very hard lesson day. I think you're going to enjoy it. We want to solve our quadratics. Call them quadratics by graphing. So quadratic is any x squared equation. Okay, that's what a quadratic is. Oops, sorry, Hannah. Get that on the screen so you can see it. Now, so we want to solve them. What we're really looking for are zeros, which are x-intercepts, and a new word, we're going to call them roots. Okay, we'll get more and more to what roots are later. But for right now, let's just keep calling them zeros, which are x-intercepts. Right, example 1. Before we start, I think it would be very handy, because we're going to do this by graphing today, okay? If you have Desmos, if you don't have Desmos, let me show you. Okay, Desmos right there. Let's see, it's kind of bright. Let's see if I can turn this light off to make it less bright. Oh, that's a little bit better. Okay, there's Desmos right there. Let me go ahead and there's my Desmos. So if I upload in my app store Desmos and hit it, I'll get a graph. See, pretty cool. All right, well, you can't see the graph. Is it too bright in my little workspace? Huh, interesting. I don't quite know why that's not working. I think that'd be too bright, but it seems like there's too much light in here. Okay, but anyway, I can also do it on my calculator, okay? That you can probably see better, all right? But you can also do this on Desmos. Because I'll tell you why. Maybe I have to put my I have to make my screen less bright. Okay, I don't know. Okay, anyway. You can do this on Desmos. I'm going to probably use my graphics calculator. I'll show you both. Okay, so example 1. This will work on Desmos. Example 1, let's find the zeros of x squared minus 4 equals 0. Okay? So think of it as y equals x squared minus 4. Okay, now hopefully you can do this on Desmos. So I'm going to do my graphics calculator. It will work on Desmos. I'm not sure why it won't show on my phone. It's almost too bright. Oh, there's my beautiful wife. It shows her. Let's see if I get Desmos again. Desmos? Still doesn't show. I wonder why. I got to turn the contrast down maybe. I'll figure that out later. Well, I don't know. Trying to figure out how to make my phone less bright. Anyway, figure that out later. Okay, so how does this graph? I go to y equals on my phone, clear, and I'm going to go y equals, I'll go x squared, subtract 4. If I graph this, it looks like that. Cool. So I'll do a real rough sketch of this. And it looks like down at negative 4, 2, and 2. Okay? And we already know how to do this. We've done this before. So my answers are here and here. Those are my zeros. That's where they cross x-intercept. So my answers are at x equals negative 2 and x equals positive 2. And those are my answers. Boom, boom. Pretty easy. Okay, hopefully you guys have Desmos because you don't have graphics calculators. Sorry about that. There's a few of you might. Okay, let's look at example 2. Example 2, I have x squared plus 3x equals 0. Okay, so if I'm going to graph it, I'm going to look at y equals x squared plus 3x equals 0. Oh, not equals 0. So if I want to graph this one, again, I would use Desmos. And I'll figure out how I can get Desmos to show. Maybe I can show way over here. Let's see what is going on. Still can't see it, can you? Oh well, too bright. I'll figure out how to change that. So let me go back to my graphics side. So I'm going to go y equals, I'm going to clear this one out. And I'll go x squared plus 3x. Graph it. There it is. Okay, there's my answers are at 0 and at 3. So I'm going to graph it anyway. Okay, so I'm going to go ahead and do this. Graph and -3 and 0. And I don't have to do a perfect job because what I'm really looking for is the zeros, and the zeros are here. There's my answer here, my answer here. So I'm going to have an x equals a -3 and x equals a 0. Okay, those are my answers. Just where it crosses the x-axis, it's called my zeros. Not too hard. Okay, example 3. Okay, I don't think this is going to be a hard lesson for anybody. It should be an easy one. Example 3. I have an x squared minus 2x plus 1 equals 0. Again, if I want to do it by graphing, go ahead and write that down. I'm going to rewrite it as y equals x squared minus 2x plus 1. I'm looking for the zeros. So if I graph it on my calculator, since Desmos won't show on my calculator, too bright, I'm going to go ahead and write in x squared minus 2x plus 1. If I graph that, there it is. Now the thing about this one, it only touches at one point. So we know that there's two answers. In fact, if you were to factor this, you would have factored into an x minus 1, x minus 1, and you do get x equals 1 twice. So x equals 1 is the answer, but you can see it from the graph. Again, if I were to look at the graph, crosses right here. The graph looks something like this. What we're looking for is the zeros. My answer is right there, and that's at x equals 1. And it occurs in a sense twice because it goes through it and then back through it again. Always two answers. This is called a double. This is called a double root. Fancy word. Double root because it happens twice. Okay. Last example. I'm done. This is a pretty easy lesson. I like that. Example 4. Okay. I have an x squared minus 3x plus 5 equals 0. Okay, last example. So, again, we're looking at graphing. Y equals x squared minus 3x plus 5. Use Desmos if you can get it on your phone. I'm going to use my graphics calculator. So I'm going to go x squared minus 3x plus 5. I'm going to graph it. Oh, interesting, huh? That tells me there's no solution because we're looking for x-intercepts. It's above the x-axis. So I like this one in a sense. There are no solutions. So I'm going to go ahead and draw a picture of that. And it's really up at about 2, 3 kind of. About there. And the graph looks something like this. 1, 2, 3, 4, 5. It's going to look something like this. And no solution because there's no x-intercepts. Okay, so Today's assignment should be pretty easy, okay? Really. And you can also do this by factoring, but we just want to show that what we're finding the answers are x-intercepts or no x-intercepts. So what we're looking at for homework should be section 4.2. Okay, that's on page, so we're going to go to section 4-2. Okay, and that is on page 118, and I want you to do 1 through 9 all. 1 through 9 all. So here it is. Okay, page 118, 1 through 9. You want to graph these so you can make it y equals x squared plus 4x. Draw the graphs. Okay, so if I draw the graphs on my calculator, let's do number 1 together so you know exactly what I want. Go to y equals. I'm going to do an x squared plus 4x. Graph that. Boom. There it is. So I'm going to put that on my graph. Seems to go through at -4. 1, 2, 3, 4, and 0. Not a very good looking graph, but it's good enough for what I want. Here's my answers. X equals -4 and x equals 0. Okay, so graph them. Show me the answer. We're good to go. Okay, nice job, guys. Keep it coming.